Say?
Slow down. As soon as I get one, we move to the next.
Sorry. So we're going to talk about rationalizing expressions with radicals in them today. Friday and Monday, we will talk about solving equations with radicals. So that'll be a 2-day affair, if you will. And then on Wednesday, we'll have a review for the exam. Your exam will be next Friday, week Friday. So, good news is we only have 2 more sections for the next 4 days. So hopefully it'll slow down a little bit. All right. Anyway, so let's talk about rationalizing today. I'm trying to be a little bit quieter because I want to leave the door because it's so hot. And there's actually a breeze that's coming in. Anyway, so we're going to talk about rationalizing. Ordinarily, we talk about rationalizing to try to get square roots out of a denominator. That was kind of where everything started with doing rationalizing. This is before calculators. So dividing by, say, square root of 2 was something that was difficult to do. But if you could take the square root up to the top and have a whole number at the bottom, then being able to do a division idea was a little bit easier. So a lot of the rationalizing stuff came out of being able to do things a little bit more easily computationally before computers and calculators came out. Now that we have computers and calculators, being able to rationalize a denominator specifically, not all that important. However, the process of being able to do rationalizing, whether it's rationalizing a denominator or perhaps rationalizing a numerator, the process is important. Okay? Our purpose, we're only going to be rationalizing denominators, but please know that the denominators, it's not anything, that it's not just denominators that you might be rationalizing. It may also be numerators going forward in another class. Okay? So anyway, but the idea here is to try to get the radicals out of the denominator if we can. That's the whole idea. So this first example we have here has just a square root of 3 in it. The idea is to try to make that square root go away. Okay. Usually, one way you may think about trying to make a square root go away would be to just square it, right? If I square a square root, it goes away. Unfortunately, if I square a fraction, it doesn't stay equal, right? So I can't just square a fraction. I want to make sure that it's the same expression. However, the idea of being able to square it is the right idea, okay? I want to try to multiply square root of 3 times itself. If I multiply square root of 3 times itself, I get square root of 3 squared, which makes the radical go away, right? So that is the right thought process. So what we'll do when we want to rationalize something like this, we will multiply top and bottom by square root of 3. This has the same effect as squaring the square root of 3, but it's not squaring the fraction, right? I'm multiplying by 1, and grab one of each of those. I'm multiplying by, I'm multiplying by 1 in a fancy way, so it keeps it equal, right? So now when we simplify this, I multiply straight across. There's not much we can do with the top, but the bottom now is just 3 because it's square root of 3 times itself. So when we just have a radical on the bottom all by itself, that's how we rationalize. So if we had something like, we'll do the next example here in a minute. Let's go down and look at number 1 down at the bottom of the page. Yep, exactly. Yep, it'll just be itself. So if we look at that 2 over the square root of 5, what do you think you might want to multiply top and bottom by? Square root of 5. Good. So then the top is just going to be 2 radical 5. Good. And the bottom will be 5. Yep. Good. Okay. Let's skip over 2 for the time being. We'll do 2 in a minute, but let's look at number 3. We've got square root of 5x over 7y. The first thing I'll do is I'll break up that radical over the top and over the bottom. So write it as square root of 5x over square root of 7y. Now to rationalize the denominator, what do you need to multiply by? Square root of 7y. Good. Yep, exactly right. Right. So we'll multiply by square root of 7y over square root of 7y. The bottom is just then what? Do the bottom first. What is the bottom then? 7y. Good. Now notice on top, we've got the product of 2 radicals. So what would I get when I combine those 2 pieces together? Yeah, we have a 35xy underneath the radical. We did those problems last time, right? Where we took one radical times another. Okay. Same exact concept that we're doing here. That makes sense? That part okay? Let's go back and catch that cube root. The cube root's a little bit different. Okay. Remember that we multiplied by just a single root 5 here, because when you square a square root, the square root goes away, right? Agreed? In order to make a cube root go away, what do I need to do? Does squaring a cube root work? Yeah, I did it twice, right? A cube root, right? Okay. So in this case, pardon me, I can make this one a little bit easier, but I'm just going to do it the other way. So if I wanted to get rid of the cube root of 4, I want to multiply it by the cube root of 4 squared this way. And I can put the squared on the inside or on the outside. Again, to make a square root go away, we want to square it. But to make a cube root go away, I gotta cube it. I can do that. I can do this a little bit more simply, but if you do it this way every time, it'll always work. I'm going to do it this way. Okay. So notice that here you would get the cube root of 4 cubed, which is just going to give you a 4 on bottom, right? Okay. On top, we would get cube root of 16, because 4 squared is 16, right? Okay. Now, I do need to do a little bit of simplifying with this now, the way I did it. Okay. So remember, we can make a factor tree. I'll do this down here. What multiplies to give you 16? We have 4 and 4, and each 4 has 2 and 2 in it. When we're simplifying cube roots, what do we look for? Groups of 3. You see the group of 3? Yeah. So how can we rewrite that cube root of 16? So that whole group of 3 2's becomes a 2 on the outside, and then there's still 1 left over, right? You see that? And now I could have multiplied these together, right? 5 times 2 would give me 10. But notice I can also now take the 2 into the 4, can't I? So we can do this as 5 cube root of 2 over 2 that way. I know cube roots are a little bit less pleasant, right? Can I do one more like that? I know there's not one on the sheet, but you want to do one more like that off to the side here? Okay. let's say we had, let's say you had 6 over, I'll try to make this one a little less complicated. How about cube root of 5? 6 over cube root of 5. What do you want to multiply top and bottom by now? Okay, yeah, cube root of 5 squared. Good. Again, if we think about it, kind of how we just simplified that cube root of 16, we're looking for groups of 3 when we simplify a cube root, right? We have 1 5. I need 2 more 5s to make a group of 3 to simplify the cube root. Does that make sense? Okay. So what do you get on bottom when you multiply that? 5, good. And then on top, all we get is 6 cube root of 25, because 5 squared is 25. And there's nothing else we can do to simplify that. 25 is 5 times 5. There's not a group of 3. Questions on that one? It's okay? All right. So when you have a single radical on the bottom, this is how you're going to rationalize. Okay. Now the trick comes up when we have a sum of radicals that I skipped over, right? So let's talk about how we do the sum of radicals. So notice this one's asking us to do something like 2 over square root of 3 plus square root of 5. Okay. Again, the thought is right, that I want to square the root 3 and I want to square the root 5. I want to square them because the square root will go away, right? That's the right thought. I want to make the square roots go away, so I want to square them, right? Unfortunately, there's a couple of things that are wrong. I can't just square a fraction. Okay, that doesn't do me any good. And even if I could square the bottom, squares don't distribute over sums. I have to FOIL, right? So just squaring the bottom doesn't help, okay? So in particular, I wouldn't want to multiply by square root of 3 plus square root of 5, because that would just square the bottom. Okay? That's not going to help here. But we're not stuck, okay? So let's remind ourselves of something that we learned back in factoring. How does a squared minus b squared factor? That's a difference of squares. How does the difference of squares factor? Told you factoring was going to come back again, didn't I? How does a difference of squares factor? If you had something like, if you had, say, x squared minus 9, how did that factor? Yeah, x minus 3 and x plus 3, right? Remember, it's a plus b and a minus b, how we factor it, right? Okay. Why do I bring this up besides to torture everybody? Why do I bring this up? Well, notice that when I multiply these two things together, I square the first one and I square the second one. Isn't that exactly what I want to do here to make these radicals go away? Okay. So how do I make that happen? Well, notice that there's a plus sign in the middle here. If I multiply it by the exact same thing, except for having a minus sign in the middle, I get a difference of squares. So this is exactly what we're going to do to rationalize the denominator in this case. We'll take our 2 over root 3 plus root 5 and multiply it by root 3 minus root 5 on top and bottom. I'm not going to worry about multiplying out the top right this second, and I don't really care that I multiply out the top. However, when you multiply out the bottom, we have to coil, right? We're actually rigging it so it multiplies the same way every single time. But remember that when we multiply this together, I have to do root 3 times root 3. What do you get when you do root 3 times root 3? You get 3, right? I get square root of 9 when you do 3, right? So I would get a 3. When you do your root 3 times negative root 5, you get minus root 15, right? Yeah. And then if I get minus root 15, what happens when you add those or multiply those together? You have plus root 15. So you have a minus root 15 and a plus root 15. Those are going to go away, right? So then do your last ones and you just get what? Yeah, so you get a minus 5, right? You do that. Notice the format we have here. It's a plus b times a minus b gives us a squared minus b squared. So it makes the radicals go away on bottom. Now let's simplify it a little bit. 3 minus 5 is negative 2. Anything go away? Anything divide out? The 2's do, right? So I can rewrite this as the negative of root 3 minus root 5. And if you want to distribute your minus sign through and reorganize it, you can. I don't really care that you do that, but you can do that. We'll do a couple more examples of this. But are we okay with this example so far? Okay. When we change the sign in the middle here and leave everything else the same, we call that multiplying by the conjugate. These two expressions are called conjugates of each other. So when you rationalize a denominator involving square roots, we multiply by the conjugate. We just change the sign in the middle. Okay? So let's see if we can do another example or two of that. Let's go down to, well, I guess another example. Okay, number 5 here. Again, if you've got a sum or a difference of radicals in the denominator, we're going to multiply top and bottom by the conjugate of that denominator. Okay? So what should I multiply top and bottom by in this case?
5x plus square root of 7y.
Good, exactly right. So I just left the top alone. I didn't distribute yet. What does the bottom simplify to? We're rigging it so it simplifies to the same thing every time. What is it going to be equal to? Get the 5x minus the 7y, right? The reason why we multiply by the conjugate is so that it squares the first term and squares the second term. So the radicals go away. And it's all, when you do this, it's always a minus sign in the middle every time. What we're doing is we're creating, instead of taking a difference of squares and factoring it, we're creating the difference of squares. We're doing it the other way around. We start with a factoring and we multiply it out. That make sense? Let's do one more of those together. Let's go over to the worksheet. We should be able to find one on there, assuming it loads. Let's look at the back side. And let's just look at part A there on the back side. So part A there on the back side has 3 over square root of 5 plus square root of 2. So what are you going to multiply top and bottom by? Good, exactly. Just change the sign in the middle, right? Multiply by that conjugate. That's the basic technique for any of these where you've got a sum or a difference. Change the sign in the middle. Now, I would recommend, at least to start, don't multiply out the top, just multiply out the bottom. Okay? Now, you may want to multiply out the top and simplify later, but at least to start with, especially when you just have a single number on top, don't multiply it out yet. Okay. We've rigged the bottom. What does the bottom simplify to? 5 minus the 2, right? Yeah. Remember, the sign in the middle is always a minus. Okay. So again, we're squaring the first one, which is just a 5. We square the second one, which is just a 2. It's always a minus in the middle. This is why I said don't bother distributing the 3 through. What does 5 minus 2 equal to? 3. And then what can you do? Cancel out the 3's, right? There's a 3 on top and bottom. Questions on that? Okay. Well, go ahead and work on those problems that are left. There's not too many left, actually. So work on those, and then I can be around to help, and I'll also project some answers up on the screen.